Okay, so we're going to start going through the exam review. We're just going to start with number 1. Number 1 is a problem about a sequence, and we're going to look at our sequence first, and we are going to write a recursive rule for it. A sub 1 is the first term, and the first term we can see is 3. Now we have to figure out what the pattern is to write A sub n. So we can see 3 times 4 is 12, and 12 times 4 is 48. So A sub n is going to be 4 times A sub n minus 1. And we want to remember that A sub n minus 1 is just is a fancy way of saying the previous term. Okay. Number 2, or 1b, write an explicit rule for the sequence. Well, we want to remember that this is a geometric sequence. And so, for a geometric sequence, our formula that we can see right in our exam review packet, right there on the first page for geometric sequence, is first term times the ratio raised to n minus 1. So, the first term is 3, the ratio is 4 raised to n minus 1. What is the 15th term? Well, that's just going to be 3 times 4 raised to 15 minus 1. 15 minus 1 is 14. I grab my calculator. I do 3 times 4 to the 14th power. And it's a really big number. There we go. What is the sum of the first 15 terms of this sequence? Well, again, we want to remember that this is a geometric sequence. And we now need to use the formula for sum of a geometric sequence. So I'm going to go back to my formulas. And there's sum of a geometric sequence. First term times, in parentheses, 1 over the ratio raised to n divided by 1 minus the ratio. So, the first term is 3. 1 minus the ratio raised to 15 divided by 1 minus the ratio. And again, this is all just going to go straight into my calculator. If you put it exactly like this, you're going to want to put another set of parentheses, like that. And you get a very, very large sum of 1,073,000,000 $741,823. Number 2, given the sequence 1, 4, 7, 10. Well, 1, 4, 7, 10 we can see is an adding sequence. That means it's an arithmetic sequence because we're adding 3 each time. Write the recursive rule. The first term is 1, and I'm just going to take my previous term, A sub n minus 1, and I'm going to add 3 to it. Now my explicit rule, now I want to remember that this sequence is, like I said, arithmetic. And so I'm going to go back to my formulas, and I'm going to use this set of formulas. So any term can be found by the first term plus n minus 1 d, where d is the common difference. So the first term is 1 plus n minus 1, and my common difference is 3. What is the 60th term? So I'm just going to go 1 plus 60 minus 1 times 3. I'm going to grab my calculator, and I get 178. What is the sum of the first 60 terms in the sequence? Now, there are 2 different formulas I can use for this. Because I've already found the 60th term, I'm going to use the second one because it's a little easier. If you already know the last term, the first term and the last term, you can use this easier formula. If you don't know the first term and the last term, you can use the second formula. But they both give you the same answer. So, it's going to be 60, which is n, and then the first term, plus the last term, divided by 2. I throw this in my calculator, I get 5,370. Alright, number 3. A balloon is filled with 5,000 centimeters cubed of helium. It immediately begins losing helium such that it loses 1/4 of its helium per day. How much helium will it have lost by the end of the 9th day? The first thing I want to realize is that this is a geometric sequence. If something loses 1/4, that means it's going to retain 3/4. So my ratio is 3/4. My first term is 5,000. So by the end of the 9th day, I'm going to use the formula first term times the ratio raised to n minus 1, which would be 8. Now to 3 decimal places, and grab my calculator, I get 4,624.577 cubic centimeters. Number 4. A theater is designed with 50 seats in the first row, 53 seats in the second row, 56 seats in the third row, and so on. So it's already giving me a sequence of 50, 53, 56, and immediately I can see that this is an arithmetic sequence. Okay. If there are 30 rows in the theater, how many seats are there? Well, now I'm looking for the sum of 30 rows, but unlike the problem up here, 2D, I don't know what the 30th row contains. So I could go and find that and use the formula that I used in 2B, or I can use that other formula. Let's use the other formula instead, so we can practice with that one. So now we're going to use this one because I don't know the last term. So I'm going to use the formula n times 2 of the first term plus n minus 1d over 2. So n is 30. 2 times the first term plus n minus 1, got the minus, times d, which is 3 all over 2. I'm going to very carefully put this into my calculator. I'm actually going to put in this numerator first, press enter, then divide by 2, then multiply by 30. And when I do that, I get an answer of 2,805 seats in the auditorium, or in the theater.